In today's digital age, large organizations rely heavily on robust and efficient networks to support their operations. These networks enable seamless communication, efficient data sharing, and overall productivity across various departments. As these networks grow in size and complexity, managing them effectively becomes an increasingly challenging task. This is where subnetting comes into play as a vital solution. Subnetting is a crucial technique that allows network administrators to divide a large network into smaller, more manageable subnetworks, known as subnets. This approach offers numerous benefits, including improved network performance, enhanced security, and simplified troubleshooting processes. Imagine a large corporation with thousands of employees and devices all connected to the same network, creating a vast and complex system. Without subnetting, managing this extensive network would be a logistical nightmare. It would be like trying to find a single book in a library with no organizational system, leading to chaos and inefficiency. Subnetting provides the necessary structure and organization, making it easier to manage and control network traffic effectively. By dividing the network into smaller subnets, administrators can isolate traffic, improve bandwidth utilization, and enhance overall network efficiency. Subnetting also plays a vital role in strengthening network security by segmenting the network. By segmenting the network, organizations can isolate sensitive data and applications from unauthorized access, adding an extra layer of protection. For instance, a company could place its financial servers on a separate subnet from its employee workstations, thereby limiting the potential impact of a security breach. This granular control over network traffic is essential for protecting valuable assets and maintaining compliance with industry regulations and standards. Furthermore, subnetting simplifies troubleshooting by isolating network problems to specific areas, making it easier to pinpoint issues. When an issue arises, administrators can quickly identify the affected subnet and focus their efforts on resolving the problem efficiently. This targeted approach minimizes downtime and ensures that the rest of the network continues to function seamlessly, maintaining business continuity. In conclusion, subnetting is not just a technical nicety, it is a fundamental requirement for any large organization seeking to optimize its network infrastructure and ensure smooth operations. Subnetting, in essence, is the process of dividing a single network into multiple smaller networks. It is like dividing a large house into separate rooms, each with its own purpose and access control. In networking, this division is achieved by borrowing bits from the host portion of an IP address and using them to create subnet identifiers. This process might seem technical, but understanding its underlying principles is key to effectively managing large networks. To grasp the concept of subnetting, it's helpful to visualize an IP address as a street address. The network portion of the IP address is like the street name, while the host portion is like the house number. Subnetting is akin to dividing a long street into smaller blocks, each with a unique block number. Just as each house on a street has a unique address, each device on a subnet has a unique IP address within that subnet. This division into subnets provides a hierarchical structure to the network, making it easier to manage and control. Network administrators can assign specific subnets to different departments, teams, or locations, based on their needs and security requirements. This segmentation helps to regulate traffic flow, optimize bandwidth usage, and enhance overall network performance. Moreover, subnetting enables organizations to make the most efficient use of their available IP address space. Instead of assigning a unique IP address to every device on the network, subnetting allows administrators to allocate addresses more sparingly, conserving valuable IP resources. This is particularly important in today's world where the number of internet-connected devices continues to grow exponentially. Subnetting offers a multitude of benefits for large organizations, significantly improving network efficiency, security, and manageability. It is a crucial technique in modern networking that helps in organizing and optimizing the network infrastructure. It's like upgrading from a one-room cabin to a well-designed mansion with dedicated spaces for various activities. Each room in the mansion serves a specific purpose, just like each subnet in a network. Let's delve deeper into some of the key advantages of implementing subnetting. Understanding these benefits can help organizations make informed decisions about their network architecture. One of the most significant benefits of subnetting is enhanced network performance. This improvement is crucial for maintaining efficient and reliable communication within the organization. By dividing a large network into smaller subnets, organizations can reduce broadcast traffic and improve overall bandwidth utilization. This segmentation ensures that network resources are used more effectively. Broadcast traffic refers to messages that are sent to all devices on a network. Excessive broadcast traffic can lead to network congestion and slow down communication. When a network is segmented into smaller subnets, broadcast traffic is confined within each subnet, reducing congestion and improving the speed of data transmission. This leads to a more responsive and efficient network. Security is another critical aspect where subnetting plays a vital role. In today's digital age, protecting sensitive information is paramount. Subnetting allows organizations to isolate sensitive data and applications from unauthorized access by creating secure zones within the network. These secure zones act as barriers against potential threats. This granular control over network traffic limits the potential damage of security breaches and helps to maintain compliance with industry regulations such as HIPAA and PCI DSS. Compliance is essential for avoiding legal issues and protecting the organization's reputation. Furthermore, subnetting simplifies network administration and troubleshooting. Efficient management of the network is crucial for maintaining its performance and reliability. By dividing the network into smaller, more manageable segments, administrators can quickly identify and isolate network problems. This targeted approach allows for faster resolution of issues. This targeted approach minimizes downtime and ensures that the rest of the network continues to function seamlessly. Consistent network uptime is vital for business operations. It's like having a well-organized toolbox, where you can easily find the right tool for the job. An organized network is easier to manage and maintain. In addition to these core benefits, subnetting also enables organizations to implement quality of service, QoS, policies more effectively. QoS is essential for prioritizing critical network traffic. QoS allows administrators to prioritize network traffic based on its importance, ensuring that critical applications receive the necessary bandwidth. This prioritization is crucial for maintaining the performance of essential services. Subnetting makes it easier to apply QoS policies to specific groups of users or devices, further optimizing network performance and ensuring a seamless user experience. This targeted approach ensures that all users have a reliable and efficient network experience. Before diving into the specifics of subnetting, it's crucial to understand the fundamental building block of any network, the IP address. This foundational element is what allows devices to find and communicate with each other, making it an essential concept for anyone working with networks. An IP address, short for Internet Protocol Address, is a unique numerical identifier assigned to every device connected to a network. Without these addresses, it would be impossible for data to be routed correctly between devices. Think of it as a digital fingerprint that allows devices to communicate with each other across the internet or a local network. Just as no two fingerprints are the same, no two devices on the same network share the same IP address. An IP address is typically represented as a series of 4 decimal numbers separated by dots, such as 192.168.1.1. This format is known as dotted decimal notation. Each number in this sequence, ranging from 0 to 255, represents an octet, and the entire address is made up of 32 bits. These bits are the building blocks of the address, and understanding them is key to understanding how IP addresses work. These bits can be further divided into 2 parts, the network portion and the host portion. This division is what allows networks to be organized and managed efficiently. The network portion of an IP address identifies the specific network to which a device belongs, much like a zip code identifies a particular geographical area. This helps in routing the data to the correct network. The host portion, on the other hand, identifies a specific device within that network, like a street address within a zip code. This ensures that the data reaches the correct device within the network. The division between the network and host portions is determined by the subnet mask, a crucial concept in subnetting that we'll explore in detail later. The subnet mask essentially tells the network which part of the IP address is the network portion and which part is the host portion. IP addresses come in 2 main versions, IPv4 and IPv6. Each version has its own structure and use cases. IPv4, the most widely used version, uses 32-bit addresses, providing a theoretical limit of approximately 4.3 billion unique addresses. This was sufficient in the early days of the internet. However, with the exponential growth of internet-connected devices, IPv4 addresses are becoming increasingly scarce. This scarcity has led to the development and adoption of IPv6. IPv6, the newer version, uses 128-bit addresses, offering a virtually inexhaustible pool of addresses and addressing the limitations of IPv4. This vast address space ensures that we won't run out of IP addresses anytime soon. Understanding the structure and function of IP addresses is paramount to grasping the principles of subnetting. Without this knowledge, managing and optimizing a network would be incredibly challenging. By manipulating the network and host portions of IP addresses, network administrators can divide a large network into smaller, more manageable subnets, optimizing network performance and security. This process not only enhances efficiency, but also improves the overall security of the network by isolating different segments.